Hello, this is a set of videos which covers the subject of electricity and magnetism as it is taught uh, from class 6 to class 10. It loosely follows the NCERT and the Telangana state syllabus. So it's meant for class 10 students to review and understand. So why do we need to study about electricity and magnetism? Do we need to understand them? The reason is that most of our technology is based on electricity and magnetism. So all our devices, our telecommunications, phones, everything uses electricity and magnetism. And some people or many people may use these things blindly, but you need to understand how they work. When did humans start learning about them? So how long did it take us to understand how electricity and magnetism work? What is the history of this? Okay, so people use technology blindly by just pressing buttons. But if everybody only knows how to press buttons, then we cannot preserve our technology. In order to preserve it, we need to understand how it works. Some of us want to become scientists and engineers, and we will study these subjects in great detail. But every one of us needs to know the basic principles of these forces. So also, when we understand the nature of electricity and magnetism and other forces around us, it allows us to understand the nature of our physical world. That makes us more rational and also responsible. It will also help you in doing well in the exams, but that is just one of the benefits. So humans knew about magnets from a very long time. So nearly 2000 years back, people knew some things about magnetism and electricity. People found rocks in nature which were magnetic, which were magnets. So there is this legend, Greek legend about Magnus the shepherd. So the magnets occur in nature as rocks. So he found that the tip of his staff, which was made of iron, was sticking to some rocks, which was very strange. So those were called as magnets. That is a story, a legend. Also, similarly, a scientist called Thales of Miletus, 600 BC, back then, he made some observations about electricity. So some simple facts were known since a long time, but from 1600 AD onwards, an attempt was made, a serious attempt was made to understand electricity and magnetism. So some of these discoveries were accidental. Scientists found things by accident. Sometimes they deliberately studied them and they improved the equipment, the measuring devices, and that way they could find more exact laws. By early 20th century, around 1910, we had already started to generate electricity and supply it to homes for light bulbs and other devices like elevators. So it took 400 years of study for to get practical results. So the 400 years of study led to practical results. You will be spending maybe an hour or two here to understand this same journey. So electricity is the basis of our technology. It is generated by using a source of energy. Sometimes you use water which is stored at a height, and that is hydroelectric power. Sometimes we burn coal and other fuels in a power plant, in a thermal power plant, and produce electricity. So these technologies, they release a lot of carbon dioxide. So there is a problem in the way in which we generate electricity. But of course, we also have alternatives like using solar power. So as time goes by, we will find better ways, cleaner ways of producing electricity. So let us start our study by looking at magnets carefully. Okay, so we have played with magnets. We use magnets to stick calendars and other things to refrigerators. Okay, so what is special about a magnet? A magnet is attracted to iron. Okay, so this kind of attraction creates a sense of wonder. It appears like magic because a small pin will jump towards a magnet from a distance. So this is a force of attraction which operates from a distance. So this was the first time humans came across such a force. Otherwise, you need to push or pull with your hand or use a string to apply a force. Magnets occur in nature. So there are rocks in nature that behave like magnets. So they are usually they contain a lot of iron ore. Okay. So this so this is how you use a magnet. Okay. So rocks containing a large amount of iron ore or magnetic. So this is a picture of a magnetite. It's a mineral. So rocks of magnetite behave like magnets, naturally occurring magnets. So they used to call these rocks lodestones in ancient times. Okay. So the Chinese and the Greeks knew about magnets and they used them. And they were fascinated by the behavior of magnets. Now let's study magnets more carefully. First fact about magnets is they attract iron objects. Iron is a magnetic substance because it is attracted by magnets. Here we have, let us check which substances are magnetic. So here I have iron keys made of iron, which can be lifted up by a bar magnet. So that is a bar magnet. Then I have a paper clip, which can be lifted up. An iron nail, which is lifting up the magnet. I have a small paper pin, which just flies up towards the magnet. So from this, I can conclude that iron is a magnetic substance. Okay. Let us check stainless steel. I have a stainless steel spoon and a magnet. So there is nothing happening. So stainless steel is not attracted by magnets. It is not magnetic. Next, I take an aluminum foil and check. There is no attraction. So the foil is not flying up towards the magnet. So aluminum is not magnetic. Then let's check silver. I have a small cup made of silver, a small vessel. So there is no attraction. So silver is not magnetic. Next, I have a roll of copper wire. it is not attracted to the magnet. Then I have a small gold ornament. Is not attracted. So that way, you can check plastic also is not, a plastic straw is also not attracted to the magnet. So iron is a magnetic substance. Aluminium, copper, stainless steel, wood, so on. All these are non-magnetic substances. They are not attracted to magnets. So there are other materials which are attracted to magnets, but we don't see them in everyday life. Cobalt and nickel are two metals which are also magnetic, but we don't usually see them in our everyday life. Then particles of iron ore are found in the soil around us. So as iron oxide particles are found. So these are magnetic. They get attracted to a magnet. So these are called as iron filings, the dust of iron, which you can collect from the soil. We call it as iron filings. So let's just do this. I have a bar magnet here, which I am dragging through some mud, soil. And some soil particles stick to the magnet, especially at the ends, at both the ends, towards the poles of the magnet. So this I can scrape off and collect. So I repeat this. I collect many times. And so I get the dust. So now this dust, the iron filings, I put it on a paper and I place the magnet below the sheet of paper. And by using the magnet, I can make the iron filings move around. So first point about magnets is that they attract iron. The second thing about magnets is that they have two poles. Every magnet has two poles, two ends, which we call as the North Pole and the South Pole. And when two magnets are brought together, the poles will either attract, pull towards each other, or push each other away. They repel. So opposite poles attract and the similar poles repel. So I have a bar magnet here. One end is labeled as N and the other is labeled as S. So North Pole and the South Pole, they have been etched on the magnet. So I take another bar magnet of the same kind. So you can see the South Pole and the North Pole stick. They attract each other. Whereas the South Pole and the South Pole push each other. They repel each other. Okay. So without even touching the magnet, you can push it away because of the repulsion. Okay. So attraction and repulsion both happen. And you can see that this force acts at a distance. No touch is required to push. Then I have, this is a ring magnet. It also has two faces two poles. So that is the south pole. Okay, if I turn it around, that is the north pole, which gets repelled. Okay, so south pole is attracted, north pole is repelled. Okay, and that is a ring-shaped ring magnet. Then I also have that is the south pole and that is the north pole. So these are two ring magnets, the opposite poles, the opposite faces attract, and the similar poles, they repel. One face is north and the other face is the south pole. I have a disc magnet. I have stuck a paper to one side, so we can see here clearly. So one face is that's the south pole. Okay, and this is the other pole. This is the north pole. So the side on which the paper is stuck is the north pole. So we have seen attraction and repulsion. So every magnet has two poles, and the opposite poles attract, similar poles repel. Now the third thing about magnets is that magnets align along the north-south direction, the geographical north and the geographical south. So what do we mean by that? If I have a suspended magnet, which is free to rotate, if I take it to any place here on the map of India, so no matter where you take it, the magnet will come to rest. If it is free to rotate, it will come to rest in this north-south direction. Okay, so this is the directionality. Magnets align along the north-south direction. They come to rest in that direction. So one pole of the magnet always points towards the geographic north, and that is the north pole of the magnet. North pole comes to rest in the pointing towards the north. South pole of the magnet comes to rest pointing towards the geographic south. Now we can make thin needles out of magnets, and these needles are mounted on a pivot so that they can freely rotate. These are called as magnetic compasses. They were used by travelers since the ancient times to point the directions. Magnetic compasses. This is how a magnetic compass looks. It's a small, thin magnetic needle with an arrow on one side, that is the head of the arrow, and the tail of the arrow on the other side. So the head of the arrow is the north pole of the magnet. It shows you the geographic north. So it is free to rotate. It is mounted on a pivot. It is free to rotate. That is, okay, so I can bring a magnet to close to that compass needle, and that needle will, so the south pole of the needle is attracted. It follows the opposite pole. Okay, so north pole is attracted to the south pole of the bar magnet. So I can rotate that magnetic needle by moving the magnet. So now I have arranged many such compass needles on a flat table. Okay, so I have left them there for a long time. So all the magnetic needles have come to rest pointing in the north-south. So in this location where the table is this is the north and the south, the geographic north and geographic south. So I also have a larger compass. Okay, so you can see that all needles are pointing in the same parallel direction. Okay, towards in the north-south direction. So I have placed the scale there. The plastic scale is showing us that same direction. It's parallel to the compass needles. That's north, south. I also have a magnet, a bar magnet suspended from using a string. So it is free to rotate, and it has also come to rest in the same direction. Okay, so that direction, north, south, okay, same as that direction of the scale. So this is the north-south aligning nature of all magnets will end up pointing in the north-south direction. So why is that so? Why does that happen? It happens because, slowly scientists realize, it happens because the Earth is itself a huge magnet. So this is Earth, and this line is the axis of rotation. Earth rotates around this axis, but near the pole, right, very close to the pole of rotation, there is a magnetic pole. And then this is the north, geographic north. So this is where our Arctic Circle is. So this is the south pole of Earth's magnet. And the geographic south, where you have Antarctica, there you have the north pole of the Earth's magnet. That is why any magnet on the surface of the Earth is attracted. The north pole of the magnet is attracted towards the geographic north. South pole of the magnet is attracted towards the geographic south. So this is how the scientists understood the north-south pointing of the magnets. Okay, so we have seen different shapes of magnets. So in nature, we know that these natural magnets occur. They occur in all kinds of odd shapes. So when people manufactured magnets, they made them in some specific shapes. So one is the bar magnet. We have seen a bar magnet, we have seen a disc magnet, and we have seen a ring magnet. There is also something called as a horseshoe magnet. This is a horseshoe magnet. It's also called as a U-shaped magnet. So that piece of iron is there for proper preservation of so these are the poles. So the ends of the U, the top tips of the U shape are the two poles of that. Okay, so you can see that is the north pole. The blue is the south pole. So this is the south pole attracted to the north pole. Okay, so this is how a horseshoe magnet looks. This is what we have learned about magnets in this video.